Hello everyone, welcome back to another video. I've not really posted that many actual videos, so here we are. This is a little bit different. It's like a VR type video, history, something. It's not really history, but it's like, I don't know what this is. I haven't watched this video yet. This video is kind of short, so we might do the take a virtual reality tour of 6 planets, I think that's what it says. But make sure you subscribe to Seeker VR, as I did right there, and like this video. Ooh, both videos actually. Here we go. Okay.
Right now you're only floating a few feet above the ground, just over 800 feet above sea level. But you're about to go much higher, on a journey to the edge of space. As far as the Seeker team knows, this is the first time something like this has ever been done before in VR. Thanks to the weather balloon above you, you'll soon reach speeds of over 65 miles an hour as you travel out of the troposphere and into the stratosphere. And you may notice this line going around. Well, that's because you're spinning fast too. But we stabilized the footage the best we could to make your ride a calm one. Now get ready, don't forget to look around, and enjoy your journey to the edge of space.
Like, how do they know I'm in VR? Oh. We're going. We're going. Alright. So that balloon's gonna take us to space. This music is actually pretty loud. Sorry. Wow. I wonder where we are. Let's see. Temperature's dropping. We're getting higher and higher. Oh! We just teleported. Alright.
The trip has just begun, but you've already flown past the tallest building in the world, the Burj Khalifa in Dubai. But the Jeddah Tower in Saudi Arabia, which is already under construction, is set to overtake it, reaching just over 3,200 feet.
Whoa, I didn't know that. Holy crap, we're high, guys. Oh, I really don't like heights. Oh, okay. We're in the clouds. I really don't like heights.
If you've ever skydived before, this is about the altitude at which you probably would have jumped out of the airplane. Now might be a good time to look down.
Oh, I'm looking down, alright. Oh, I don't like this. Oh, I don't like this at all. Okay.
If you listen closely, you can hear the precipitation inside this cloud. And if you look up, you can see it falling down around you. At this altitude, the temperature is so cold that what you're actually seeing is sleet and snow.
What? It's 13.
We're coming up to the height of Mount Everest, the tallest mountain in the world. Its peak is about 2,700 feet above what mountaineers call the dead zone, where oxygen is too scarce to breathe.
Are we going into space now? Going to space, guys.
And just a short distance above Everest Peak is the cruising altitude of commercial flights. Look around to see an angle of the world you wouldn't normally see sitting in an airplane.
Space, guys.
It may not feel like it, but you're traveling at over 65 miles an hour,
Holy crap,
ascending
I didn't
at
know
more
that.
than 1,000 feet per minute.
It's
This
negative
might be
16
because we hit the
degrees.
jet stream, a current of fast-moving air cutting through our atmosphere.
It is negative 16 degrees. Negative 25 degrees? Okay. We're starting to lose speed. But we're getting there.
Right now, the air pressure is about 90% lower than it is back on the ground, close to the atmospheric pressure in
Down.
space. Under
like
these
this.
conditions, your body would not be able to survive without a spacesuit.
Oh, good thing I'm in VR. Okay. Wow. So is this the edge of space? Or can we go higher?
This is about the altitude where our cameras died. However, the balloon didn't. It kept traveling to a height of over 114,000 feet, where, because of the drop in air pressure, the helium inside expanded so much that the balloon burst. The cameras and equipment fell back down to Earth, where our Seeker team tracked and found it, everything still intact, and just a few miles from where we launched. We had a plan to go to the stratosphere, to bring seekers like you to a place that you wouldn't otherwise be able to go, to experience the world from a new angle, to take you to the edges of the Earth.
Seeker, edge of the Earth. Wow. That was really cool. Alright. That was really cool. Wow. Big shout out to all these people on here. Wow. Alright, so next one is we take a virtual reality tour of 6 planets, I think that is. Exoplanets. Oh, we're in space now. Milky Way galaxy.
Come in. Hello? Is anyone there? Can you read me?
Yes.
There you are.
Yeah, I can hear you.
Beautiful, isn't she? The Milky Way galaxy. And to think, each one of those 100 billion stars has its own planets, its own strange worlds. Imagine what it would be like to visit some of those exoplanets beyond our own little solar system. Well, today, you don't have to imagine, because I'm going to take you on a tour of 6 real exoplanets. What you're about to see is based on the latest scientific research, and as we travel across the cosmos, we'll hear astrophysicists
hold on. Sub to We the Curious, and like their video and this video, because this is I wouldn't be able to see this without these two. Alright, just go sub both of them. Seeker VR and We the Curious. They're amazing.
The University of Exeter tell us about their search for planets beyond our solar system. So, if you want to experience what it might be like to stand on another planet, I highly recommend strapping on a VR headset and a pair of headphones to feel truly immersed.
Guess what, fam?
Feel free to pause the video here whilst you get what you need to start your journey. Okay, are you ready?
I'm ready.
Let's go.
Let's go. Oh! Oh, is that Saturn? No, it's planet LKCA 15b.
I'm Elizabeth. I'm studying observations of debris disks and trying to find debris disks and giant planets. So the planets will form over maybe 4 or 5 million years as the star forms. So the star forms out of a massive cloud of dust and gas, and that collapses down, and the centre of that will fall inwards and become a star. But then there'll be a whole cloud of dust and gas and stuff left, and that kind of collapses down into a disk that's just made out of kind of the leftovers from the star formation. And then that disk, the individual bits of dust will collide to each other, and they can sometimes stick together. We don't really understand that yet. Sometimes they stick and sometimes they bounce off, and no one really knows how they can stick together enough to start to form a planet. But then as soon as you have a big core, we call it a planetesimal, so it's maybe 10 kilometers across.
Lady, I don't know what you're saying.
That's big enough that its gravity starts to scoop up all of the rest of the nearby stuff, and then it kind of slowly picks up more and more bits of dust and gas, and they fall down onto the surface, and eventually it grows into something like Jupiter, or even bigger than Jupiter.
Lost signal. Alright, going to the next planet. This is Mars? No! No, planet Wasp, negative 121b.
I'm Professor David Singh, and I study transiting exoplanets and their atmospheres. Well, hot Jupiters are gas giant exoplanets, but they orbit much, much closer to its star than Jupiter does to our own sun. In fact, they orbit so close that the day side of the planets are heated up to thousands of degrees Kelvin. And because they're so hot, a lot of the atmosphere around the planet actually evaporates off, sort of like when a comet gets too close to the sun, you see a lot of evaporation of the comet happen. A similar process happens for these planets. They orbit so close, a lot of the atmosphere is being blown off. Because these planets are so close, we expect them to be tidally locked, which means the same part of the planet will always face the sun. And what that does is set up a very large day-night contrast in temperature. It's very hot on the day side, and it will be quite a bit colder on the night side. And this will in turn create large-scale weather patterns around the planet. This planet is so close that the tidal gravity is starting to distort the planet itself. If this particular planet was any closer, it could actually break apart.
Whoa.
But what might it look like inside the atmosphere of one of these extreme gas giant exoplanets? Let's find out.
Okay, I want to find out. This is interesting, guys. What is this? Osiris? Like YK Osiris?
My name is Stefan Lines. I'm an exonephologist, which is someone who studies clouds on extrasolar planets. So what we're looking at is planet Osiris, otherwise known as HD 209458b. And these are extremely strong winds, going from the west to the east of the planet, from the day to the night side. The wind speeds are reaching about 5 kilometers per second, which is about 10 times faster than Concorde. Osiris has a temperature of around 1,000 degrees centigrade. With these temperature ranges, we're not really looking at water clouds like we have here on Earth. But at these much higher temperatures, we have the sort of evaporation and condensation cycle of things like iron and silicates. So these planets might actually have molten iron rain and silica or glass rain, which is incredible because with these wind speeds of 5 kilometers per second, you're effectively going to be lacerated by this glass rain and molten iron. So these aren't particularly great places to visit.
Why would you want to visit this thing? This thing looks like I could kill you in like 10 seconds. Back on Earth? We're on a planet? Bruh.
My name is Nathan Main, and I study the atmospheres of planets
We've discovered around distant stars. Our next destination is the surface of a water world.
Oh,
This is
my
a
lord, look
super
at
Earth,
these waves.
as it's called. In our own solar system, we have no planets which exist in the size range between Earth and Neptune. But actually, as we observe off into the galaxy, we find this is one of the most common form of planets. We think that many of these have kind of rocky cores. They're terrestrial planets essentially, but they're likely to have
I don't like
a
water either,
huge
guys.
ocean. Now they're super Earths. They're much larger than Earth. They might have much stronger gravity.
The only thing that
and
I'd
they
like if
probably
I'm,
have much
if I'm
thicker
on the water is
atmospheres.
if I have a fishing
That
pole.
means any land features
And,
that are on these planets, any rocky features,
not as rough
are going to
waves
be
like
weathered
this.
and
What the
suppressed
heck
and
is
effectively
this?
destroyed.
Oh,
You can see
my lord.
the surface is being distorted by
These are like
huge waves.
tsunamis.
There's many reasons that could cause these waves. You have
Like,
an ocean which is not
going
interrupted by
over
land
and
masses.
over and over
So
just around
many
this
of these
planet,
planets
like,
we
it's like
expect
a
could
roller
have
coaster.
moons or multiple moons even,
An infinite
which
roller
create
coaster.
the same tidal effects that our own moon causes in our oceans on Earth. Additionally, actually, many of these objects might be undergoing significant tectonic activity beneath the surface of the ocean, and these waves have no land mass to crash into, so they really can build to quite substantial sizes.
Okay, next planet. Show me what you got. Show me what you got, space. Okay. We're not on a planet. We're on this thing called
Our next destination is
The surface of 55 Cancri E. This planet orbits so close to its central star, it's incredibly hot. We think
Yeah,
temperatures of a
looks
few
like we're
thousand
literally
Kelvin or
living
3,000
in a
degrees.
volcano.
We know from how much this planet wobbles its star due to its gravitational attraction that this planet is about 8 times the mass of the Earth. And we also know from its sort of transit, when it eclipses the central star, that it's probably about twice the diameter of Earth. So this planet is incredibly hot and has a very strong gravitational field. So what you can see is a molten lava field underneath you, where the surface is being disrupted and melted, and much of that material could potentially be lofted into the atmosphere. And what you end up with is a very soot-laden atmosphere full of particulate matter, molten rock and condensing rock, and raining sort of silicate particles. And you're going to have huge amounts of charged material flowing in the atmosphere, and that will lead us to have significant thunderstorms. So effectively, this is a pretty nasty place, probably as close to Dante's Inferno as you can imagine, with a molten lava surface, raining rock, and constant planet-wide lightning storms.
I would hate to be here. Not like I'd ever want to go, but if I ever end up here. Oh, you have an ad, guys. Hold on. All right, we're back, guys. Where are we now? Whoa, what is that thing? Is that the moon? What is that? What is that? Planet Trappist.
My name is Jessica Spake, and I'm interested in studying exoplanet atmospheres.
Yeah.
Trappist 1e is a fascinating system. It was a wonderful surprise to find 7 fairly Earth-sized planets so closely spaced together around this tiny star. The star is actually about the size of Jupiter. It's really like a solar system in miniature.
Do you know how
here
big
you
Jupiter
can see
is?
the stars a lot cooler, redder, and smaller, and you can see it actually looks very big in the sky here. That's not because the star is bigger, that's because the planet is a lot closer to that star than we are to the sun. So these planets can be very close in and still be kind of about the same temperature as Earth.
Oh, we're already over for this one. I don't think they have much information about this one. This was interesting, guys. We're back in the Milky Way.
We have discovered over 3,000 exoplanets, but we've only searched less than 1/1,000,000% of our galaxy. There are billions more worlds out there for us to find in the Milky Way, and billions more galaxies beyond our own. Each new planet we discover changes how we view the universe and our place within it. But so far, we've only found one, planet Earth.
Oh.
Thank you to everyone who helped to make this video possible. If you enjoyed it, please share, subscribe, and check out our previous videos. Thanks for watching.
Only one. This.